So remember, in the case of type 1 diabetes, the juvenile onset, somehow the immune system attack the pancreatic beta cell so that the patient of diabetes cannot produce insulin. And when we don't have insulin, then it decreases the glucose uptake by the cells, meaning that our body cell cannot absorb glucose from the blood into the cytoplasm. Absorption of the glucose into the cell, of course, for one, it can, after it absorbs to the cytoplasm, then the enzyme in the cytoplasm can convert glucose into glycogen. But remember what we talked about in the type 1 diabetes, the VMN cell require insulin so that they can absorb glucose into the VMN cell, so that VMN will tell the human to stop eating. And also the alpha cell, the pancreatic alpha cell from the pancreas, they also require insulin so that to absorb glucose. And if the alpha cell does not have insulin, that means they cannot absorb glucose into the cytoplasm. They will think that, oh, your body is still low in glucose. If your body is low in glucose, then what happens? Then the alpha cell will continue to secrete glucagon to break down more glycogen, or basically to increase the blood glucose level. Even though you already have a high glucose level in the blood, this is what it means. When we don't have enough insulin, then a lot of the body cell cannot absorb glucose into the cytoplasm. Then most of your body cell will think that, oh, okay, your body is low in glucose because I don't have any glucose in the cytoplasm. Then what would they do? They will continue to do glycogenolysis, meaning that they will continue to break down glycogen to form more glucose. Or they will do gluconeogenesis in the liver. Liver will continue to do gluconeogenesis to make the glucose level high in the blood, because the liver cannot absorb any glucose. They will think that, okay, your body has a low blood glucose level. And then your blood plasma will have a very high glucose level. We call it hyperglycemia. Hyperglycemia, meaning that your blood plasma has a lot of glucose. And then what will happen? When we have a lot of glucose in the blood, then the renal filtration of glucose and ketone will increase. Remember that where does it occur, renal filtration? It occurs in the Bowman's capsule and glomerulus. But you may think that, how come, isn't that we learned that the filtration, the filtration is 100%, all the glucose and all the ketones and stuff, they will go into the renal tubule. We call it glycouria or ketouria. Remember that in the proximal convoluted tubule and distal convoluted tubule, all these, they will absorb almost all the glucose back to the blood. But in this case, in the case of diabetes, you have too much. You have too much glucose in the blood. You have too much glucose in the blood, and so after the filtration occurs, you still have a lot of glucose in the blood, meaning the filtration is not 100%. It's not 100% going into the renal fluid. And also the glucose transporter to transport glucose from the renal tubule back to the blood vessel also saturated because you have a high concentration of glucose in the renal tubule, so that the glucose transporter originally used for transporting glucose from your urine back to the blood, that they already work in the maximum rate, and that will cause us urine. You have glucose in it, that causes glycosuria and ketonuria. And then because you have a high concentration of glucose in your urine, what will happen? Your water will go to urine. Because urine is concentrated, then water will go from your blood to go to the urine to try to, it is called osmosis. And then you will decrease the blood volume, decreasing blood volume, decreasing the arterial blood pressure, the MAP, and then you have less blood to go to the brain. And then when you have less blood to go to the brain, you can have a brain dysfunction, coma, or even death. On the other hand, when you don't get enough, when the body do not produce enough insulin, so that your body think that, okay, you have a low blood sugar level because none of your body cell can absorb glucose, then your body will automatically break down lipid or the adipose tissue to make more glycerol and fatty acid. Then you have a lot more fatty acid in your blood, and the fatty acid can be converted into ketone. If you remember the post-absorptive state, it happened in the liver. And then the liver, because you have a lot of ketone converted by the liver, then this can go to the blood and cause something called acidosis. We call it ketonemia. Anemia meaning a blood disease with too much ketone. Ketonemia can be acidic and causes acidosis, and it will cause this similar effect. That's why diabetes is very dangerous. So in the next video, we'll talk about type 2 diabetes.